minus 8x, factor out an x, and then you have two separate factors that you can set equal to 0. So 0 equals x, and 0 equals x cubed minus 8. This one's solved. When you add 8 to both sides and take the cube root, you should get that x is equal to positive 2. Okay, and that's the only solution. If you had negative 2 in there, you would end up with negative 8, and that doesn't work. So we have to go from 0 to 2, x to the fourth minus 8x dx, and this should be really straightforward to integrate. I have a feeling this one was calculator active, but I'll go ahead and write out the algebra that I did. When you sub 0 in, it just becomes 0. I skipped a step. Sorry. 1/5 x to the 5th minus, this child needs to go to sleep. 4x squared from 0 to 2. Then hop down to that step. You can't see. I'm sorry. Freaked my talk out. Okay. And then you should end up, when you simplify all of this, with, did I really get a negative solution? Hold on. Let's go back. Oh, it's going to be so long. Oh, yeah, it should be negative because it's all underneath the x-axis. Okay, here we go. Oh, why would I do that? Okay, here we go. Where did the ladybug screen go? Okay, I'm sorry. Here we go. All right, so yeah, negative 48 over 5 units squared. Ta-da. All right, number 5. This one was nice. 1 to 2. Oh. 1 to 2 of 6 over x squared. This integrates to negative 6 over x from 1 to 2. Because this is x squared, you can rewrite it as 6 times x to the negative 2 because it was in the denominator. And then when you add 1 to the power, it becomes negative 1. So that's what this is there. And then this ends up being negative 6 over 2 minus negative 6 over 1, which should end up giving you positive 3 units squared. Okay, and then number 9 was a little long, but that's okay because I'm pretty positive it was calculator active. So for part A, I think that was the one that most people wanted. Yeah, 9A was like the issue. So for 9A, the first thing you want to do, because you get something, if I recall, like this, and so you have a positive piece and a negative piece. And so you have to split up that integral into 2 pieces and take the absolute value of the second piece. So our area is going to be defined by these 3 places. And so we have to find all of those roots. So we set 0 equal to x minus 2, and x plus 3. They did a really nice thing and factored everything for you. So you should just have x equals 0, x equals 2, and x equals negative 3 as your 3 roots. I also wrote this out so that I could see what it is for, see like what the polynomial was, x cubed plus x squared minus 6x. For when I integrate it, because I was an idiot and integrated by hand when it was calculator active. Oh, sorry. My allergies are really bad today. But let's not be an idiot like I was. Let's just put it all in. So we'll have x minus 2, and x plus 3. Stick it in there, hit graph. Oh, what's wrong? Oh, my window's bad because my daughter was playing with my calculator. Okay, there's our function. And then what we want to do is set up our integral. So the first thing we want is this positive piece. So our area is going to be equal to the integral from -3 to 0 of our function plus the absolute value from 0 to 2 of our function. Okay, because this piece is negative, we want to force it to be positive by taking the absolute value. So the first thing I want to do is do second calc, and I go down to number 7 with the integral sign. My lower limit is -3, my upper limit is 0. It tells me that this is going to be 15.75. And then this piece, we want a second 7, lower limit is 0, upper limit is 2. It's going to give me a negative number. Oh, and I want the fraction, so it's like a perfect, a rational value, a value that has no extra decimal things. Oh, she's finally asleep. That took her forever. And I'm putting it in the absolute value to force it to be positive. When I add this together, so 16/3 plus 15.75, I should end up with 253/12 units squared. Okay, so that's part A. And then I think that a lot of people also got mixed up because then in part B, it asks you specifically not to find the total area, but to calculate this particular integral where its limits are -3 and 2. We don't break it up at the 0 where, how does this happen? We don't break it up at the 0 where we have like the positive area and the negative area. When we actually do this, we can do this in our calculator. Second calc 7, lower limit -3, upper limit 2. So we're not like doing the smart thing. We're forcing it to do exactly what we want. So I get my answer, math enter, and this gives me 125/12 units squared. This is different because I didn't separate out my areas, okay? I didn't keep track of which piece was negative. This one would be considered my displacement. It would be like walking along a line and then going backwards and asking how far did I go from start to finish? Like maybe I started here, went all the way over here, and then went back, but stopped here. So my displacement would be this much because that's how much I changed from start to finish. The total distance that I went would be calculating all the way along here, doubling this piece, and then adding this, or yeah, and then stopping right here. Okay, so that's the difference between those two things. C, they don't match because B, fine, I'll write it. Actually, it's in the other solution. I'm not writing it. They don't match because B counts the 0 to 2 interval as negative instead of forcing it to be positive. Okay. Number 10 is the last one in this section. I think 4, 5, 9, 10. Yay. So this one gives you that pi over 5 is equal to the volume from 0 to a of this function. Okay. And so all it wants you to do is solve for a. So we have pi over 5. Oh, I just went ahead and canceled out my pi on each side for the first step. And then we end up with 1/5 equals the integral from 0 to a of x to the 4th dx, because to x squared is x to the 4th. And then this gives me 1/5 x to the 5th from 0 to a, 1/5 a to the 5th minus 0, because 0 subbed in right here is going to give me 0. So this, if I bring my 1/5 down, was equal. Now notice I have a 1/5 on both sides, so I end up with 1 equals a to the 5th. Take the 5th root, and a should be 1. Okay. Then there were questions on properties of integration number 15 and 16. Here we go. Okay. We pull up properties of integration. So I've written everything down now. Now we're good to go. Number 15, it gives us this. It wants us to find these guys and then k. Okay, so for the first one, oh, well, this one just should be this. So for our first one, oh, wait. So do you see how the limits of integration are switched? It's just the opposite. So this is just -4. Tricky. And then here we have the same boundaries, but we have this extra 2. So we just like want to integrate that piece. So we would have the integral from -1 to 1 of 2 dx equals the integral from -1 to 1 of f of x dx. Oh, plus, not equals. And then I did this in a really, really bad way. This should end up being, so the integral of 2 is 2x. So I have 2x evaluated from -1 to 1, and then plus 4, because that's what that second piece is. And then when you do 2x, when you sub in our 1 and -1, I should get 2 times 1 is just 2, minus -2, and then plus 4 at the very end from my second piece right here. And then 2 plus 2 is 4, 4 plus 4 is 8. So that should be your final answer there. And then here, I can just pull the 2 out front. So this is really just 2 times the integral from -1 to 1 of f of x dx. Our limits of integration are the same, so this is just 2 times 4. So this is 8. Okay, then it asks you to find the value of k such that that thing is equal to 7. So basically you can pull k out in the front of the integral, and then we have our -1 to 1 f of x dx, and that whole thing should be equal to 7. We know that this piece is 4, so k times 4 should be equal to 7. Solve for k by dividing by 4 on both sides, and you should get that k is equal to 7 over 4. Okay, so that's 15. Then 16 says if g of 2 is 4, g of 3 is 5, calculate this. So we have the integral from 2 to 3 of g prime of x minus 1 dx. This means that I can split up my integral. So 2 to 3 of g prime of x minus the integral 2 to 3 of 1 dx. Okay. So when I integrate g prime, I should get g. So this is g of x evaluated from 2 to 3. This one is going to end up being x. 1 integrated is just x from 2 to 3. Okay, so then we get g of 3 minus g of 2 minus 3 minus 2 when we sub in 3 and 2 right there. G of 3 we are given is 4. No, incorrect. G of 3 is 5. G of 2 is 4. And then 3 minus 2 is 1. 5 minus 4 is 1. 1 minus 1 is 0. The end. Okay, I miss you guys a lot. Good luck out there. I will see you guys next time. Good luck on your test next class. I'll make another video. So I'll get to say hi again. And maybe I will have washed my hair next time. It's been like 4 days. Hope you guys are living your best lives. Bye.